This administration is so anti-nerd that it feels like a personal attack, not just on me, but like the whole country.
That's Kate Marvel, a prominent climate scientist who resigned from NASA last month after more than a decade at the agency. Kate always thought that she was going to work at NASA forever. It was her dream job. She even worked at NASA during the first Trump administration. But this time around, she says things are way different. And this new, super anti-science Trump administration is what forced her hand. Since Trump's second term started, more than 10,000 federal employees with STEM Ph.D.s have left the government, mostly through layoffs, firings, and buyouts, and more than 7,800 research grants were terminated or frozen. Paired with the restrictions that Trump has been placing on federal science, Kate says that it just became impossible to do her job. I'm going to read a little bit from her resignation letter. You should definitely read it all if you get the chance. But in it, she wrote, "I anticipated that our work would be questioned, but only because its implications were politically inconvenient. I never expected that science itself would come under attack, simply because it, like journalism, history, and even the best kind of art, is a way of seeking the truth. I'm leaving because I want to tell the truth." In our conversation today, Kate Marvel tells the truth about what's happening to federal science in the Trump administration. We talk about the work she was doing at NASA before Trump, why that work was important, and why the Trump administration would want to make that work difficult to accomplish. We also talk about one side effect of Trump's attack on science that rarely gets talked about: the loss of nerd culture, and why that culture is actually really important to democracy. Then, in the extended conversation for paid subscribers, we keep going into one of the most controversial questions in climate science: geoengineering. We talk about what it means to study technologies that could intentionally alter the climate system, and why the collapse of trusted public science makes those future decisions even more dangerous. We also get into our feelings about the state of federal science and the strategies we're deploying to not just cope, but fight back. Here's my conversation with Dr. Kate Marvel. Enjoy. Hi, Kate Marvel.
Emily, how's it
It's
going?
going really great. Thank you for being on the podcast.
Thank you. I'm so excited to be
You
here.
have been a really great and trusted source for climate science issues for me over many years. And when I saw the headline about you leaving NASA in a fury, I was like, oh my God, that's one of the best climate scientists that I know have known in my career. So what happened?
First of all, thank you so much. That's so nice, probably overly generous. But, I really wrestled with this decision, right? Because who leaves NASA? That is the coolest job ever. But it was chaos. And there are some people who can work through chaos, who can just be laser focused. And I was really having a hard time getting science done. Every day we would wake up and be like, well, is this the day we get fired? We would write grants, they would disappear into black holes, or you would hear back that, oh, this is a great project, we really want to fund this, but we have no idea if there's going to be any money. And because you're getting no information from the high ups, it's basically just rumors swirling around. And I really struggled, right? Because I think there is a place for folks in the government trying to hold things together. But it was my job to do science, and I just felt like I couldn't do science in this context.
This is a nerd's worst nightmare.
Right? Right?
You got your dream nerd job, and all of a sudden, like, you cannot be nerd.
Yeah. Yeah. I mean, I think that's a great way to put it. Like, this administration is so anti-nerd that it feels like a personal attack, not just on me, but like the whole country.
I've never thought about it that way, but it's actually true. Because especially in science, like, the concept of nerdiness is that I'm going to go down a rabbit hole that no one even thought about going down, or so specific or so weird. And it sounds like what's happening in the federal science space is that, like, rabbit holes are being covered up. It's like you can't go down rabbit holes if they're not the preferred rabbit holes of the administration.
Yeah, and those rabbit holes are pretty stupid. You they're relitigating questions that we know, right? It's sort of like the equivalent of asking what happens when you mix vinegar and baking soda, right? Like this is a known question. And I guess that metaphor breaks down because it's not going to kill you if you don't know that. But, pretending, oh, we really don't understand if vaccines work. No, we do. We know that vaccines work. We don't know if climate change is happening. Yes, we do. We know that climate change is happening. We don't know if it's caused by humans. Yes, we do. It's caused by humans.
Yeah.
And so I miss my rabbit holes because I knew that my rabbit holes were maybe eventually going to lead us somewhere better.
What were the questions and the rabbit holes that you were diving down in the good old days?
Yeah, I kind of my research followed two basic, like, but related tracks. So one was, what does climate change actually mean? And on one level, like, we know what it means. It means the temperature of the earth goes up. Like, and that's settled. Like, we are so sure that when humans put greenhouse gases in the atmosphere, it makes the planet warmer. Like, we're more sure about that than we are that smoking causes cancer. But how that translates into changes in what we actually experience. So changes in drought risk, changes in rainfall, and especially extreme rainfall, this, really heavy stuff, these downpours that are leading to floods. Um, Things like the seasons, things like the timing of the monsoon, those are questions that are more difficult to answer. And so I was working in a field called essentially detection and attribution. So what does climate change look like? And do we see it in the data? And if we don't see it in the data, is it because it hasn't come yet? Or is it because there's something fundamental that we don't understand about the Earth system? So that's kind of bucket one of my research. And bucket two of my research was in feedbacks. So we don't have a great understanding for what the Earth does when you increase carbon dioxide this quickly. And the reason we don't really have that good understanding is like we've never done this experiment before.
Yeah.
And so we know that as the Earth warms, stuff on the Earth changes. And those changes can in turn feed back to the warming. They can make it worse or they can kind of dampen it a little bit. And it was my job, it was one of my interests to try to understand and constrain some of those feedback processes to
Is
sort of.
one of the examples of that like the feedback loop of permafrost melting? So it's like increasing temperatures causes permafrost to start melting, and then that in turn releases more greenhouse gases into the atmosphere because it was trapping
So that is
carbon.
a great question, and that is going to send me spiraling down
Okay.
another nerd rabbit hole. So you might be sorry you, you
Okay,
asked
it's
that.
fine. Or is
So
that a feedback loop and you're
so
talking
we
about feedbacks?
no, but we can. The reason it's a good question is it gets at something really fundamental about the Earth system. So we can break feedbacks down into sort of two basic categories. One is if you double carbon dioxide in the atmosphere. So suppose you just like snapped your finger and all of a sudden there's more carbon dioxide in the atmosphere. What does the physical Earth system do? And so those feedback loops are things like, well, it gets warmer, so you melt ice. Ice is very shiny and reflective. And so when you melt the ice, you get more absorbent surface below, and that makes it warmer. So that's an example of a
Mm.
destabilizing feedback. What you're talking about is an example of what we call carbon cycle feedbacks, is as the earth gets warmer, how much carbon dioxide is going to be and stay in the atmosphere. And right now, about half of the carbon dioxide that human beings emit into the atmosphere gets taken out. It gets taken out by stuff that photosynthesizes, stuff that uses carbon dioxide to make more of itself. So plants, phytoplankton, etc. There's no guarantee that that is going to continue into the future because it is really hard to take carbon dioxide out of the atmosphere if you're on fire. So we know that as the climate changes, it's going to be harder for some growing stuff to continue growing in the places where it currently grows. And so that's an example of a
Mm.
carbon cycle feedback.
Yes. Okay. And I have another nerdy question to ask you now that we're just like on this loop. AMOC, the current. the Atlantic. What's the M word?
Meridional.
Meridional. A word I've
Mhm.
never heard. Yeah, the Atlantic Meridional Ocean Current. There's this huge discussion now about whether climate change is going to cause that to weaken or collapse. Is that an example of a feedback?
That's an example of what we call a tipping point. So a feedback is something that the climate changes or you get more carbon dioxide in the atmosphere, and that makes stuff change, and that makes the temperature increase faster or slower. Something like, I'm going to just call it AMOC because I can't
Yeah, I
reliably
can't do that.
pronounce meridional.
You did a great job, but
Thank
yeah,
you.
I
Thank you.
understand.
Um, that's an example of something that is commonly called a tipping point, which is basically breaking something on the earth that you can't fix on timescales that are relevant to human lives or human civilizations. So, another example is disintegrating something like the Greenland ice sheet or the West Antarctic ice sheet. When that happens, you can't very easily refreeze a giant ice sheet no matter what you do. And so once that stuff is gone, it's gone essentially forever from the perspective of human beings.
Right.
Um, and so something like AMOC is talk about things that like get oceanographers fighting with each other. AMOC is basically you've got cold water that doesn't get made into ice in the North Atlantic, sinking and kind of forming a conveyor belt that moves along the deep ocean before eventually coming to the surface and sort of starting the cycle of moving heat around again. We know that that is weakening. The evidence is really solid that that's happening. And a lot of people totally freak out about this. They say, oh my God, the Gulf Stream is going to shut down. That's not true. The Gulf Stream is what we call a wind driven current. And so as long as the Earth is spherical and turning, there's going to be a Gulf Stream. Um,
That's good.
I I hope that we're not, I mean, there's probably some proposal that I haven't read yet to like make the Earth not a sphere anymore. I don't know. Like so many
But is it
terrible
really a
things are
sphere,
happening.
Kate?
Is it really a sphere? Yes.
Those are the kind of questions that the Trump administration wants NASA scientists to start
God.
answering.
And so, but basically, like Gulf Stream's still going to exist. But the problem is that as that current weakens or even shuts down, what you get is a big pileup of cold water in the North Atlantic. And that's not going to cause like a day after tomorrow scenario where everything freezes and you've got like wolves in New York City for some reason and like Jake Gyllenhaal's in the library burning books. Like we're not going to get that. But what that does mean is that regional temperatures and rainfall patterns, especially across Europe, are going to change substantially. And that will have massive implications for like who can grow what crops where.
I mean, even the reason I'm bringing it up is that these are big questions, scientific questions that are disputed. What's going to happen to AMOC? What are the feedbacks that are going to happen? They're things that we need to know to
Hmm.
make good policy choices and to protect ourselves and to prepare for what's coming and to really cement into our brains that we really need to do more mitigation to solve climate change, right? These are like
Yeah.
essential scientific questions. And it sounds like these are what federal scientists at NASA and other scientific agencies are supposed to be studying, right?
Yeah.
But it sounds like what you're saying is that that's not happening.
Yeah, I mean, I want to be really clear that there are amazing scientists still in this organization who are doing amazing work and fighting really hard to keep doing amazing work. And so I think it's really important to recognize those folks. But we are losing something, and not just at NASA, but the NSF, the DOE, the NIH, these sort of big government funders of science. When we lose that, we lose not just the scientific research that otherwise we would have benefited from, but we lose kind of this neutral arbiter of the science. And I'm not saying that scientists are not human beings with our own values and preferences and feelings, but we're also nerds. And when you have big federal systems full of nerds, indoctrinated in the culture of being nerds, of always asking questions, of changing your mind when the evidence dictates that you should change your mind. If we lose that sort of universally agreed upon source of objective reality, I think we just have massive problems as a democracy going forward if we don't have things that we can all agree on.
How is the Trump administration specifically changing or harming the culture of federal science? That culture that you speak of, this like nerd culture where we look at the evidence and we change our mind if there's a problem and yeah, how are they changing that culture?
At the highest levels, putting like political appointees in positions that are fundamentally not supposed to be political. There have been a lot of these newspaper reports of Doge going through grants and automatically canceling or refusing to review grants with specific bad words, things like diversity or woman or climate or future or earth.
Woman,
Um,
famously political word.
exactly.
What is a
Um,
woman?
should they vote?
These are the federal science questions the Trump
Hmm.
administration wants us to answer. But carry
Exactly.
on.
And as a result, there is kind of this reflexive urge to self-censor.
Mm.
And it comes in part, it comes from a good place. It comes from well, I think this is an interesting question. And if I change a word here and there, am I going to be allowed to continue asking this interesting question? But that is obviously a slippery slope because you start changing words in a way that is very like moral and defensible. And where's the limit? At what point do you say, I have fundamentally altered the research question? So there's this, having to hide things is very, it does things to you. It does things to your science. It does things to like your soul as a person. But, also the fact that they're slashing funding. They are saying the science should reflect the administration's priorities. And, those priorities are not really things that are compatible with the best available science.
It's interesting though, because yes, the Trump administration slashed a bunch of funding for science, went in and did cuts and firings, but you still had a job. So what did your job look like and why were you like, I can't do this?
My job was to do science, and it was really unclear how long that would continue. It was unclear what exactly I was supposed to be doing because, again, I'd written grants saying, I want to do this project. They had been peer reviewed. We had been told, okay, you can do this project. This sounds like a good idea, but then there was no money. So I'm good at making work for myself. I'm good at continuing to do the science, even when it's not really clear exactly what I'm supposed to be doing. But every day we'd wake up and think, are we going to get fired today? Are all of our grants going to get canceled today? What words are we not allowed to use today? And it felt that at the highest levels, instead of saying, we value your science and here's how we're going to protect it, we were being told things like, make sure you take your pronouns out of your email signature. Like that was the highest priority.
That's so annoying, by the way.
Mhm.
Ugh. I
The
mean,
greatest problem facing America.
I hear what you're saying about the administration and political powers that be driving employees to self censor to protect themselves. I feel like that's a lot of how censorship winds up working in scientific environments and journalistic environments. And I say that because I've experienced it myself. It's not that you get a directive from the top being like, don't say that, although we do have that from this specific administration being like, don't say these words or your grant won't get funded, right? So you have to avoid them, right? You self-censor in that way. But then there's just this overall knowledge that if you do a certain thing, you're going to get looked at.
Hmm.
And so you do anything you can to not get looked at. And I'm assuming that's what you were seeing in
Yeah.
NASA.
And, the thing I think that is most insidious about it is that initially it's not cowardice. It's kind of the opposite. It's I am not going to comply with this, but if in changing a few words, I can protect the people who work with me, I can protect the work. That's really important. I don't think it necessarily comes from a place of like, oh, I don't want them getting mad at me, so I'm going to censor myself. This work is too important to not do. And therefore, I'm going to figure out a way to continue to
Yes.
keep doing it.
I say, like
Um,
in journalism, it's like, how can I get this story out, this really important story, in a way that won't get like the super higher ups to be like, hey, you did a story about climate change. It reminds me of like doing a story about sea level rise on military bases, right? When I was working for a conservative news conglomerate, it's like, okay, this story is so important to get out to their audience. How can I do it in a way that's not like overtly big screaming climate change story that will definitely get the higher ups to be like, why are we running that? You know?
mhm. And, in some respects, that's an interesting exercise, right? That's how do we be creative about looking at this problem from all angles? It forces you to stop using your jargon. It forces you to stop telling the story in the same way over and over and over.
Yeah.
So, that can be a really good thing. But when it is the federal government saying, don't say these things, I think that's completely different.
So you were at NASA during the first Trump administration as well, correct?
Yes.
What was different then between that administration and this administration that made you be like, I can't do it anymore?
I mean, the first time we had an administrator who was essentially a NASA fanboy. He really loved NASA and he wanted to take care of NASA. And we were very largely protected from political interference the first time around. This time around, it felt distinctly different because of the chaos. We had an administrator who was nominated, then he was unnominated, then he gave $1 million to a Trump PAC and he was renominated. And one of the last straws for me was reading an interview with him in Science magazine, which is kind of the one of the leading journals for nerds.
It's
And
like nerd newspaper. Yeah.
it's nerd newspaper. And in this interview, he said, well, it's just not good for NASA to be seen convening scientists or publishing papers on politically controversial topics. And I was like, it's not our fault it's controversial, Jared. Um, and that
Of course his
really,
name is Jared.
of course, his name is Jared. Sorry, I'm sure there's nice Jareds out there.
I I have friends named Jared.
Okay, apologies to your friends named Jared.
Sorry.
Uh, but this particular Jared just did not give me a lot of confidence that he was going to stand up for our science. If you looked at what was happening to our colleagues at NASA Goddard Space Flight Center, which is the big center in Maryland. They were being kicked out of their offices and their labs. Their library was shut down. And all of this was sort of proceeding for no clear reason that anybody could really explain. And it just felt like an assault on a scientific facility in a blue state for the purpose of assaulting a scientific facility in a blue state. And we had been kicked out of our office space. NASA, or Doge rather, had closed down our offices in New York City while the government continued to be on the hook for the lease, so paying rent on an empty building. And, this wasn't a decision that made sense from a economic standpoint. It wasn't a decision that made sense from a scientific standpoint. It just felt like chaos and destruction for the sake of chaos and destruction.
You are a really great representative, I feel like, of scientists because you are a good communicator, which can generally, I think, be hard for people sometimes who are just so in the weeds of things all day. I think you do a really good job of like summing things up. What can you communicate about the experience of federal scientists overall under this administration?
I think there is a certain amount of bewilderment. A lot of scientists were the kids who got the A's in school, the kids who worked really hard, the kids who went to graduate school, the kids who sat down and really kind of wrestled with the math and the methods and the sometimes like really boring, hard slog of science. And most of us did that kind of under the assumption that, well, universally, everybody thinks this is a good thing to do. It is good to cure and prevent diseases. It is good to do research and development that then filters down into the private sector and makes a lot of money for people and boosts the economy. It is good to have information about the weather, about the climate. And, I think we all kind of assumed that this was universal, that, essentially everybody believed it. And it has been a shock. And, a lot of people are saying, well, you guys are so naive. And maybe we were. But it has felt very shocking to be attacked for doing the science. I kind of expected that we would be targets as climate scientists. What I did not expect was that they would go after pediatric cancer research first. And that has been very, very confusing. Why are we under attack? What did we do wrong? Why does everybody hate us all of a sudden?
Do you have any idea?
And, I totally out of my wheelhouse, but I think, there are politically motivated attacks on science. I think the conclusions of climate science are, we know, very inconvenient to a lot of people. But I think there is a more general attack on science, and I think it completely mirrors the attack on journalism, because I think science and journalism are both trying to do the same thing, just on different timescales, right? Like, we are trying to figure out what's true, and then we're trying to tell people about it. That is both of our jobs. And when you have alternate sources of finding out what's true, and sometimes if what's true contradicts what the administration is saying is true, that is very, very, very threatening to the administration. I think you see that in authoritarian regimes worldwide and throughout history, that you want to have a very tight grip on the control of information. You want the government to be able to say what's real and what's not. And like George Orwell, articulated this really well, right? Like, if the party says 2 + 2 = 5, 2 + 2 = 5. And it doesn't matter that that's transparently wrong. You don't need federal scientists saying that's wrong. The point is to force loyalty to the regime by getting people to go along with things that they know are wrong.
It's so
And
so
yeah,
dark.
it's so dark. But I don't know if you feel this way, but as I became an adult, I was like, oh, those stories that they read you when you're a kid, where there's good and there's evil, those are totally unrealistic. That in the real world, everything is nuanced, everything is a shade of gray. And that has been very, very interesting for me to be like, no, wow, there's good and evil. Like, this is so you know, in this particular scenario, it is so obvious to me what the right thing to do is. The battle between scientists and authoritarians. I'm not saying scientists are perfect, but I know what side of this divide I'm on.
Yeah. This NASA administrator, Jared, I keep, NASA Jared, I keep thinking about that quote that really sent you over the edge, which is that I don't think it's good for scientists to dive into controversial topics. And it occurs to me, like, who else besides scientists would you want to dive into controversial topics? I mean,
Right.
what are we not getting done? What do we lose by avoiding our federal scientists diving into controversial topics like climate change?
I mean, a lot. I think especially because this is not a hypothetical. Climate change is happening. It's happening now. It will continue to happen. Even if I snapped my fingers and overnight humans stopped emitting greenhouse gases, the temperature would stop changing. But at the same time, there is climate change baked into the system. Even if it stops warming, the climate is still out of equilibrium. It's going to take a very, very long time for the deep ocean to start responding. And so that means that there is a certain amount of sea level rise baked in. And we are not in any imminent danger of reducing emissions to zero. So we know that climate change will keep happening. This is a reality. And being able to have the information we need to prepare, to cope, to face it, to adapt, that is really important. And then as it gets worse and worse, we're going to start seeing ideas being floated, right? We're going to start seeing people saying, well, let's try to somehow refreeze the ice sheets. Let's try to suck carbon dioxide out of the air and bury it. Let's try to block the sun by spraying particles into the stratosphere. And all of those things are controversial, and all of those things are going to require trusted scientific input. I'm not saying scientists should make these decisions. I absolutely do not want to be in a position where physicists have to make social decisions that affect, billions of people. But I do think that we need to have that information on the table to make decisions. Um, we need to know that if you spray stuff into the stratosphere, it will probably make it colder. But we need to understand the implications for the ozone layer, the implications for things that grow on the Earth's surface, the implication for precipitation patterns. And we need to have that information coming from a trusted source that doesn't stand to make a profit from doing this or not doing this. So I'm really worried. I'm worried that humanity as a whole is going to have to make decisions to do these things, to not do these things. And if we don't have a knowledge base, that is incredibly dangerous.
Yeah, I guess the follow-up question there is you're saying that the federal government is the best place to do that type of science, to be the arbiter of this research, right? I guess, can you tell me a little more about why you think that is? Because there are other research institutions that could potentially do this science. Why does it have to be the federal government?
Well, most basic science is federally funded. So even if there's a university that's doing scientific research, a lot of that funding will come from federal sources. So the NSF or the NIH or NASA funds university research as well. And the reason we do that is everybody benefits from this, but there's no clear profit motive to find out stuff about the world. Once you find out stuff, then there is a clear profit motive to use it, to do things with it. But there is there has been this recognition that that can't be left to the private sector. And there's been this sort of consensus ever since World War II that this is a good thing, that we get enormous return on investment for every dollar that we spend on research and development. And I think the fact that we spend more on research and development than any other country and we have the biggest economy. Like those two things are not separate from each other.
Yeah. I also want to go back to what you were talking about spraying aerosols in the atmosphere and using geoengineering. I recently came across this excerpt from Human Nature, your book, that you had published in the Wall Street Journal, of all places. The headline of that Wall Street Journal article is, "To fight climate change, we need to start hacking nature." It kind of makes it seem like you're saying that in order to fight climate change, we need to start geoengineering the planet. We need to start spraying aerosols into the atmosphere. Is that what you were saying?